In this video, we're going to take a look at moving into reflections and glide reflections. So we're going to be able to see what those look like. And another isometry is going to be a reflection. Remember, an isometry doesn't change the size or the shape of an object, and a reflection simply flips it. Think of when you look at your shirt in the mirror, your lettering is backwards, and that's a great illustration to show our students. Because a reflection is going to change the interpretation of what's happening. So one example would be the mirror. We could also talk about two people facing each other and mirroring each other, and having the class examine that, like what it takes to actually mirror one another. And our reflection is going to be a line. It's a transformation in a plane, if I'm using a line, where every point is moved across this line of reflection. Now, when I say moved across, it has to maintain the same distance, and we're going to get an idea of what that looks like in just a minute. We can obtain a reflection in different ways, depending on how we want to think about it. We could fold paper in half and create this reflection line, and everything on the left and the right of that reflection line should be the same. We can also work on giving a mirror image, like the half tree here in part C. We can also stimulate a reflection by actually using the paper perpendicular to another sheet of paper. If I want to construct a reflection, again, this is the dying art. If you actually want to go through the construction process with them, you would draw a line of reflection and you would work to have the students create a mirror image on the other side of the line of reflection. This is a beneficial activity for them to struggle just a little bit to get that it's going to flip, okay? So if I'm constructing this mirror image, I'm going to use the line of reflection, and I'm going to make sure that when it's reflected, it's the same distance. So notice that AB is the same distance, but that the line is facing out, going another way. That's because it's being reflected. If I did this with a triangle, I kind of do this by, if I move B is one diagonal away, so it's going to be one diagonal away here. A is going to be down below B, that's going to create the down below B here. So I'm reflecting on a slant, which is especially challenging there as well. If I'm reflecting in the coordinate system, I get really happy because it's way easier to do in the coordinate system than it's going to be to do in an actual drawing. So if I am reflecting across the line y equals x, you just switch the x and the y values. That's how you reflect. If I'm doing that, so here I'm switching the x and the y values, and it's a really easy reflection. If I'm looking at the light reflecting from a surface, so from my science class, I'm going to talk a little bit differently about reflections, because there I'm looking at something bouncing off a figure and it's creating that image. And so what we understand is when a ray of light bounces off a mirror, that angle there, it's formed from the angle of incidence, is going to be congruent to the angle of reflection, which is why things are going to look reversed in a mirror. A glide reflection is actually a simplistic version of a reflection. It is a transformation, it's a translation followed by a reflection in a line parallel to the arrow. So there's my translation, and then I would do a reflection. So it's almost as if it's two different steps, okay? So when I'm looking at this, I'm doing two unique steps. I'm doing a translation and then a reflection. And when you do both, that's going to be considered a glide reflection. Now, if I'm looking at congruence with isometries based on what I've looked at, is it possible to have two figures that are congruent, if and only if one is an image of the other under an isometry? So the answer is yes. If I'm looking at this rectangle and I want to describe some sequences that are going to map triangle ADC to triangle CBA, I want to describe it as a mapping process. So I could do a half turn. That's one way to do it. I could also do a glide reflection perhaps, or a maybe there's just different ways to get there, and realize your students are going to see different ways of doing it as well. So in these, a reflection is going to be a way to get those two triangles mapped onto one another. And some students, when you have your upper level students, they may want to do something like a translation, then a rotation, or a glide reflection. And if it's possible and it maps it, then it's correct. So just be willing to think out of the box when you're working with your students, because a lot of students are going to be very intuitive visually, and that's definitely one of the fun parts of being a teacher.